Okay, so here we are looking at how to control the speed, and we use something down here called PWM, or pulse width modulation, and you're going to look up how that works on YouTube. It's a lot of good videos on how pulse width modulation works. Essentially, it's a way of tricking the motors into thinking that they're getting a lower voltage than 3.3 volts by turning the motors on and off very, very quickly. And basically, when we say very quickly, about 50 times a second is what we're going to be doing. So the PWM, we're going to set it up first. So we have to set up each channel as we go through. So I'm going to set up the first channel, and I'm going to call it RMF, so right motor forward, underscore PWM, which is an unfortunate name, but that's what I'm going to call it, is equal to GPIO.PWM, and it's going to be on the right motor forward, RMF, and it's going to be at a frequency of 50 Hertz, which is 50 times per second. And we're going to start that channel straight off. So RMF underscore PWM dot start, and that will start the channel working. And we're going to start it on a setting of 0, so it's basically going to be turned off. If we started at a setting of 1, it would move very slowly. If we started at a setting of 100, it would move at full speed. So 100 is full speed and 0 is off. So basically we've got that happening. And now we need to set up a Pwm test area. So begin Pwm test, and I'm going to print out that we're doing test as well, because that way we know that we've actually got it turned on. Pwm test. Okay, so in this test area here, we're going to scroll down a bit. In this test area here, we're going to basically do some weird thing where we're basically going to call in RMF underscore PWM, and the command is very, very ridiculous. It's called the change duty cycle, and that's because this is the duty cycle. This is how many times it's turning on and off, and they call that the duty cycle. So we're going to change that duty cycle, and let's just change it to 10, and then we're going to do time dot sleep, and we'll sleep it for 1 second. It's up on blocks for me, so it doesn't matter. You should probably do this on the floor. We're going to do RMF underscore PWM dot change duty cycle for, let's just go 80, and you'll see the difference. And we're going to go time dot sleep for 1, and then finally we're going to go basically, well, let's just copy this so we don't have to type it out again. Control C and Control V, and we change that to 0. So it's going to go slow, it's going to go relatively fast, and then it's going to stop, or it's going to stop providing power. So let's see what that looks like. I'm going to press Control Save to save that now and run it. So run the module. Looking at the robot, we should see that the right motor should start spinning slowly, faster, and stops. And you can see it doesn't stop straight away, it coasts because it's got a bit of momentum to deal with. So let's actually make that a bit more obvious by putting in, making this 3 seconds and making this 3 seconds. So let's just save that and run that again, just so that we can see it on the screen. There's the robot ready to go. Slow, fast, and then stopped. Okay, so that's basically what we need to do. You're now going to have to do an experiment where you're going to play around with some different values and make some observations. So you're going to have to draw up a table, and in that table you're going to have to draw up the difference between frequencies and the difference between duty cycles. And it's going to be for both motors and how they interact on different surfaces as well. So we've got a carpet and we've got floor. So can your robot start at, for example, at a duty cycle of 1 on the carpet, or does it need to be higher? What's the minimum speed? What's the maximum speed you should be going, or the maximum speed you're comfortable with going? And you can play around with what those speeds are. So basically, create a nice big table with different duty cycles, different frequencies, testing the different frequency ranges. So starting from, let's just say 10 hertz and going through to 500 hertz, and each one testing different ranges. Record your observations and see what you learn.